Dr. T. Israni ma'am for the presentation. Please ma'am.
All these will come in introduction chapter. Okay. So then paragraph level outline. Just now I said problems these sections means indirectly you have prepared the table of contents. Okay, table of contents is ready with you. So then you can elaborately write each and every paragraph. If it is a report writing, you have to make it more elaborate. If it is a paper writing, paper publication, you have to complete it within 1 or 2 sentences. Each thing. Okay. Next. The same points I have continued because in the paragraphs you will have to quote sometimes refer flow charts, tables, figures, all this, because many times a complete paragraph which is explaining the figure may be kept in a simple figure. It can be understood by a simple figure. We need not explain in 10 or 15 sentences. So always try to replace with suitable figures over whole of that matter. Okay. So you can save more of documentation pages. Okay. Next, the overall approach is very important. See, multiple stages of refinement is required here. You can take feedback from your guide, peers, your friends, or coordinator, advisor, instructor, whoever are there available to you. You can take always the feedback for what you have already done. Okay. So the general idea is like this. You have to start with anyway title is ready, abstract, introduction. So abstract you are going to write individually. I am going to explain all these once again in the next slides. All these things you are going to have. Just now I already mentioned. Abstract, introduction, what is the background or motivation, past or related work, literature survey, technical sections, project work done. This is not numbered properly. That is not saved. See, the first one is title of the project. Title of the project is very important because the selection of your topic for publication is mainly based upon the title. Okay, some of the points I will cover here for publication also parallelly, so that I need not take more time on paper publication. Okay, look at this. This is a title where the problem is well defined and solution is also stated in a single phrase. Okay, so that is what we are going to consider here, but it should not be a poor definition. Let us suppose we have done a simple thing, full add. You are able to reduce the delay, so you have named it, indirectly you have increased the speed. So you have named it high speed full add. Alternatively, you can write it more sophisticated way like this. The design and implementation of a high performance full adder for high speed arithmetic computation. Full adder is nothing but arithmetic computation block, so you are using it in arithmetic computations. So indirectly you have mentioned the application. Wherever arithmetic computations are there, you are going to use the full adder, right? So a better way of defining it, you can consider the title like this. Next is the abstract. See, abstract is the summary of, here I suggest you to have 3 paragraphs in report writing and 1 paragraph in paper presentation or paper publication. 3 paragraphs should be of like this. First one, the main motivation should be given. If you are doing a paper on image processing, what is the need of the topic that you have chosen? Okay, so that thing should be there, or VLSI, or embedded systems, whatever it is. Okay, so what is the main motivation or need of it? In the second paragraph, you can consider the main design point, essential difference from the previous work, and the methodology adopted in the second paragraph, and in the third paragraph, some eye-catching results and highlights if any, and also the hardware, software that you are using in this work. Okay, so all these 3 paragraphs must be there for an M.Tech project report writing. Okay, if it is a paper publication, you can finish all these in a single paragraph. Okay, so that is what is abstract. See here, a specification or design or a procedure that is not fitting in a single page cannot be understood. Okay, this is a quotation, means if you are writing the abstract so many pages, means you have already kept all the unnecessary matter into it. Okay, it means. Next one is the introduction. See, I have a list of questions here. If you are able to answer all these questions, your introduction is very perfect. I made a thorough research on this and I have kept almost all the possible questions here. See this, what is the of the problem or area? What is the setting of the problem? What is your actual topic of research or what is your actual topic of project? What is the area of your project? Okay, give me the background. If you are able to explain the background, that is first point. Next one is, what exactly is the problem you are trying to solve? The problem statement. Yesterday I have given you an example about car, right? So when there is a problem in the closing of the window mirror, how we have stated the problem statement example I have given yesterday, right? So you have to write this statement properly. What is the problem existing? What are the existing methods? How you are solving? Yesterday I told you, even though manually you can close the window mirror, but despite the existing method, we have to make it automatic because all the time the driver cannot close and open the mirror, right? So that is the point. Why is the problem important to solve? This is motivation because there is a damage of the window mirror many times. Is the problem still unsolved? What is the password telling you about it? Is it still unsolved or solved to some extent? Still there is some work to be done, like this. Why is the problem difficult to solve? Why is it difficult? What is the challenge in them? What is the challenge? You can concentrate on the challenges also. Okay? So that is another point. How have you solved the problem? What is your solution to the problem? Keep it as a simple thing. Okay? Because this is introduction. There is a place where you have to explain it elaborately. Okay? What have you solved? How have you solved the problem? The approach stated explicitly. The statement of assumptions you can also include here. Means what are the conditions under which the solution is applicable. You have found a solution, but it is not universal, right? At what initial conditions or at what assumptions you could solve this. You have come to this conclusion that you have to mention. Next, what are the main results? The summary of the results. What is the summary of your contributions? It helps to state contributions explicitly. How much you are contributing will make you the more important or give you the more credit. Okay, so what is your contribution is very important. How is the rest of the report organized? The thesis organization you can put it in the first introduction chapter itself, right? The next one is literature survey. See, the information that should be known or understood by the reader. See, we are thinking of the third person in our mind. This is not for us, this is not our area, I already told you. We are writing the report for third person. Somebody else is going to read it. Okay, not for your guide, not for you. Your guide knows what you have done, you know what you have done. But we are writing it for the examiner or the third person. So how it should be? There should be the enough background, enough knowledge about the background so that before they have looked into your actual topic, they should get some idea on what you are going to do. Did you get me? Are you with me? Now, the minimum knowledge that should be having for the third person you are mentioning here. Let us suppose a project report come to me on low power. I already know about low power. Whatever literature survey you have written on low power, I can skip it. Okay. So all the matter that you have written over there can be skipped by the person, third person, if they already are into that particular area. Okay. That is the idea. Next. The discussed topics from the books and papers are to be included in references. Let us suppose you have taken some matter. Okay. How the robot is implemented. You have taken one paragraph from 2012 publication. Okay, author name is so and so and published in so and so journal. The title is so and so. All that you have. You have to keep it in a square bracket. Reference number 1. You have taken this matter. Okay. So without quoting the reference, you shouldn't take the matter. That is a crime in publication. Okay. As far as report writing is concerned, it is okay. But for paper publication, it will come under plagiarism. Okay. What other people did on this topic? What other people did on this topic? So you will be having some knowledge in the same topic, or you can see into the papers what are the topics mentioned and related topics, what is the matter mentioned, we have to keep some analysis, okay, of it. Problems and shortcomings of their work. If there is some problem in other work, you are going ahead with some other idea, right? So what is it? Discuss how your work is different and better. How your work is different. Any relevant and specific information regarding hardware statistics, equipment use, prototype, etc. Okay. Next, literature survey is done. Now, you have to concentrate on the technical section. Technical section is not simply what you have done written in one paragraph. It has to be in at least 2 or 3 paragraphs. Not paragraphs, 3 chapters. 2 or 3 chapters means what you have to do. You know, it is a single title first. When you have started with, it was a single title. Next, you have elaborated in 3 paragraphs. Next, what is the previous or related work existing? You have kept in literature survey. Okay, are you with me? Next thing is the important or heart of the document is this work. What is our proposed work? What is our proposed work means the design of the work. What is the block diagram? What is the flow chart? How you are going to proceed with the problem? Okay, all that you have to consider the design part. First chapter means this will come under 3rd chapter in the order. Okay, in the second one, the 4th chapter of report, you will have to write the implementation of that. Implementation of that. How you are implementing the proposed work? Sorry. How you are implementing the proposed work, and the discussions on the methods you have adopted and procedures followed. How you have developed that coding, what are the conditions to fulfill so what assumptions you have made, all that you have to keep here. Okay. Special equipment and hardware setup. If it is there, you have to include that also. I have continued this to elaborate and discuss. The organization of the report we have already mentioned. The first one is introduction, literature survey. Okay, and the 3rd one is your proposed work. 4th one is implementation of the proposed work, right? So the organization of the report is problem specific. This particular section, if you want to have a separate chapter, I mentioned it as a section, keeping it in my mind as a paper, but it is a chapter. Okay, so what is proposed work? If you want to include some flow charts, figures, tables, anything if you want to include, you can include here, use of figures. And the important point is terminology. What terminology you are using? See here, define each term and symbol before you use it or right after its first use. Okay, so somewhere you have mentioned it as K and KP, somewhere the same variables you are referring to them as mu and μp. It's not correct. Okay, somewhere you have mentioned the parameter pressure to be P, somewhere else you have mentioned it as K. That is not correct. Okay, so follow the same notation in the entire document. Make sure that all diagrams, graphs, etc. are properly labeled and have a caption. You have kept one diagram, one figure. What is it? We don't know. Below the diagram or below the picture, you have not written anything. Why you have kept it? We don't understand. And the other problem here is you don't refer it in the document. Let us suppose you have named, caption is there, figure 1, block diagram of the proposed work. But figure 1 is never quoted in the document. We don't know why you have kept this figure here. Whether it is related to the topic or not, we are not sure. Did you get me? Always you should refer the figures and also the tables used in the document. Okay. Next thing is results. Discuss the results for different input conditions. One case you have taken, you have kept it is never correct. If the system is working for one set of inputs, there is no guarantee that it is going to work for all set of inputs. At the same time, you cannot do exhaustive testing. So you should have at least 4-5 different cases, right? So that you should proceed. Better to have comparison tables. If at all you have comparison tables for power supply voltage 1.0 volts, 1.5 volts, 1.8 volts, like the different comparison tables you have, you keep them, okay, for different conditions. Next, show the output of waveforms in case of simulation. if you have done the simulation, you must keep the waveforms. Otherwise, if you mention it A equal to 0, B equal to 1, C equal to 0 is given as input, the output S is equal to 1, C is equal to C, carry is 0, it doesn't look good because it is from the truth table. Truth table also says the same. By writing A equal to 0, B equal to 1, C equal to 0, S equal to 1, C equal to 0, it doesn't give the appropriate look. What does it mean? You have done the work means you have the simulation results, you have the waveforms with you, then you should keep them. It is a proof that you have done, right? Next, keep the pictures of prototype if a model is developed. Let us suppose you have a model on a PC or you have some other robo model, some embedded systems, home automation model you have. Okay, so that prototype picture you have to keep it in the document. Okay, in the results. Next, develop the graphs to observe the variation of parameters with respect to other parameters. Let us suppose with respect to time you are varying power, with respect to time you are observing the speed, all this. Okay, let us suppose you are developing graphs in MATLAB, you do most of the time, right? So when you are developing, you are observing one particular variable with respect to the other, always it is better to show it in terms of graphs. Okay. Next, conclusions and future scope. This is the last paragraph, last chapter of your document. Okay. So conclusion and future scope should consist of all this. First one, give conclusions with assumptions or initial conditions. How you are concluding, there should be some specific reason why you are concluding like that. It is not universal always, right? So under what initial conditions and under what assumptions you have come to this conclusion, that should be clear. Next, what are your achievements? You are concluding your achievements here. Approaches, methods, procedures, your research goals, have you met it? What are your goals, have you met it? What is the success measure? How far you could reach that? Did you get the point, the success measure? The other day I have explained this, right? 10% you could improve the performance, 20% you could improve the performance, like that you should mention. Next, hardware statistics, difficulties eliminated, conditions improved, what are the limitations still existing, and what is the future scope to avoid them or to extend the work. Okay, all these should be there in conclusions and future scope. So next you have to keep the references like this. Deliberately I have kept this example, like if you are taking particular paper from journal, how you have to code. If you are taking a particular paper from conference, how you have to code. If you are taking it from a textbook, how you have to code. This is the method how you have to code, right? So the example is like this. The author name should be first. If multiple authors are there, you have to write like this. Then the title in the double quotes. Okay, comma. From which journal you have taken, volume number, publication year, everything like this. Okay. Similarly, this is a conference paper. The authors, comma, title is the double quotes. Next, what is the name of the conference? What is in the proceedings, page numbers, and where is it held, and year. Okay. So like this you have to put. Similarly, if you are using any online material like this website, okay, and if you are using any patenting work like this, and etc. Okay, you have to use like this. The references format should be like this exactly. Next, appendix. See, whatever you wanted to convey to the other person, or you want to keep it for yourself for the future reference, you can keep it in the appendix. For example, I have named here the software tools, hardware tools, design procedures, coding of the design, additional theory existing, additional specifications of the hardware. If at all they are there, you can keep them for yourself. Okay, at the end of the report. So the summary is like this. The title of the project is important, the abstract also, and the chapter first is nothing but introduction. The second chapter is literature survey. In detail I have explained all this. I am giving a summary of it, right? The third chapter, design of the proposed system. Fourth chapter, implementation of the proposed system. Fifth chapter, results. Sixth chapter, conclusion and future scope. Okay. The other time I have found a student writing the chapter names. First one, introduction. Okay. software requirement, third one hardware requirements, and a conclusion. In the conclusion, he explained about research ethics. So documentation is over in 17 pages. Never it can be in 17 pages, right? So you have to maintain all this. Next, the arrangement of the book should be like this. Okay, they will give you, the coordinator will give you. The first it should be a cover page. Next, inner title page, same as the cover page. Declaration, certificate, acknowledgement. So you can thank everyone those who have helped you in your project. Abstract, 3 paragraphs. Table of contents, list of tables, list of figures, abbreviations, different chapters. The previous slide I have shown you all these chapters. Okay, and a list of chapters, references, appendices. If you have published any papers on this topic, you can mention them here. Not others publications. Others publications will come under what? References. Very good. Thank you. Next, self-assessment. This is a checklist, right? So whether you have done all this, you are going to check once again. If I read it out, it will be a repetition. Okay, you are able to see that now. So you have to check for the title, abstract. Is it making a sense? Whether title is there or not, you are not going to check. You are going to check whether it is making a sense or not. Okay. Now you have to read with third person's mind, not with your mind. Okay. You have already written over. While checking is going on, you have to think in view of the examiner. Okay. Like the examiner, you have to check. Does the problem statement effective or eye-catching? Are you able to present your problem properly? At the end of the job, are you finding that you have not at all defined the problem? Whatever is existing, that only you mention. Sometimes it happens with the students' reports. Okay, look at it. Are all the relevant questions answered in the introduction? I mentioned many questions in the introduction, right? So all of them are answered or not? Next, the overall structure of the rest of the sections meaningful. Whether you have made a meaningful organization or structure. Then, is the difference from related past work meaningful? You are doing research or you are doing your project in VLSI and you have got some related papers on embedded image processing. It is just because they meant somewhere there is a word VLSI. It should not be. Did you get me? So, related past work is meaningful or not? Are the technical sections understandable? Whatever the way you have done in your own language you have written, done. But is it understandable by the other person? All the figures, tables are explained properly. Is the terminology clear? Are the symbols used defined appropriately? Are the results explained properly? Are the conclusions drawn from the graphs, tables sound? Do the results show the work presented to be better or worse than the other comparison? You assume that you can show 20% of performance improvement, but when you have done at the end, you observe that the power savings you couldn't make. To your bad luck, the percentage of power consumption increased. What will you do? What will you do? You have to change the method you have followed. You shouldn't write it. If the results are like previous work shows there is 20% of power savings with the previous method. Okay. But using this method, there are no power savings. It is consuming 30%. Okay. What you have to do? You have to check if there is increase in speed, if it is consuming less area, such parameters you can quote. Otherwise, you have to say by using this method, this is consuming more power. So this method of or this procedure to reduce the power is not advisable. That you have to make a sentence like that. Next one. Follow the test formats as specified. The coordinator will give you the text format. The heading should be 16 font, side heading 14, font size. Okay. And the paragraph text should be of 12. Okay. All these font size we should follow. Or proper units mentioned to the quantities. The other day we have done very good research work on logo. Finally, she has written it was 360 nanowatts of power consumption is there by the entire system. Okay, whatever she has done. She has written 360 watts of power consumption. Nowadays, even the electrical power systems are not consuming. Some of them, not all. She has written 360. She has done the final binding also. To her luck, HOD has observed and she has changed anyway, that is different thing. You better concentrate on the units and quantities how you are mentioning, okay? So this is the checklist. Here I have closed the report preparation. M.Tech project report preparation is done. And madam is looking at me, I have to check that. Next, paper publication. So if the students are interested, they can listen, and for our faculty friends also I am trying to give this information. Okay. Paper publication. See, the reading maketh a full man, conference a ready man, writing an exact man. I hope everybody understood. Okay. Reading maketh a full man. If I read everything, I am confident I can write the example. Okay. You are ready. You know something. Whether you are able to write the example or not is dependent on question paper, of course. Next one is conference a ready man. You are ready for conference. Okay. So on one particular topic you have gathered enough information and you are able and you are confident that you can present well. Okay. The last one is writing makes an exact man. Most of us are not able to write the things properly. Okay. So this is where we are lacking. So we have to become an exact. How we will become? By writing only. Rewrite, rewrite, rewrite. Okay. Not imposition. Not same thing you have to write. What you have to do? Make modifications, make corrections and write. Next. The tips to the author. Three important things I consider and next move to the paper headings. Okay. Choosing an area of current interest and importance. This is very, very, very important. What is the current area of interest? We should not select 1987 paper, 1847 paper. Are there papers during that time? They are there. Jack Ilfey has published papers. Okay. So he has invented first integrated circuit and has got some other patents also, right? Now, you are not going to do the 100 years back work. What is the recent research work and what is the present topic of interest? That you have to select. This is very, very important. Next, I will give you a tip. Basics of the topic. What are the important basics that you consider about this particular topic that you have selected? Okay. Next, what is the motivation to this topic and how you are going to manage with the structure of this? So, in the structure, you will have to provide the clear motivation for your paper, and the structuring of the paper is must. You have to make it well. Then you are going to write all this. In every paper, there should be abstract, introduction, related work, proposed work, results, conclusion and references. Okay. You keep them on your tips. You just have to elaborate them. Get the information and do the elaboration. That's all. At the end of this presentation, I am going to show you how to get a paper from the entire document. Okay. Yes. So this is to select an area of importance and interest. Do as much background as required. The second one is choose a topic that will be interesting in future, not in the past. Previously, all of them were talking about robots. Okay. Previously, all of them were talking about IC design. Now, as a fresh, I will start a new IC design flow. logo. That is not correct. It's already there. It was past interest. Now what is the trend? There are many applications being developed on robo. Many applications, not home automation. Many other things are coming on automation, right? So those things you should put interest on. Not the previous existing networks. If some prototype is taken, simulated for many times, that is not the same thing. You are going to do it, repeat it many times. Okay. So previously they have taken one protocol, now they change the protocol, run it again. That is not the story. That is not the idea. Okay. Go ahead with the future interest. Next. Attend the main conference in your area of research or area of interest. Then you will get the topics covered in the conference. And the last 1 year conference papers you can see. You get the idea of it. Next, what are the research interests of the technical program chairs? Sometimes they call for conference papers. They ask for papers in the area of image processing, in the area of embedded systems, in the area of wireless networks. There you have to select. Okay. So you send a paper on that. Just because you have done on something else, VLSI, you shouldn't send it to the wireless, right? So you have to select the area properly. Next. Speak with your professors, identify the research interests or areas of work topics acceptable and published in their journal. This grade is for chairs and the editor of journal I am referring to. Okay. So whatever interests are there, present interests are there, if you are not able to decide with, to speak to professors or the people who are working at research. Okay. There are many research scholars in our college who are doing their PhD. Okay. You can ask them. Look at the most recent issues of the journal. You have seen one embedded systems journal, IEEE Journal of Embedded Systems. But in that journal, what are the topics mentioned recently? Not 12 years back, 20 years back, right? If the papers have been, what sort of papers have been published? What have been the subjects of recent special issues of that journal? Okay, those things you have to concentrate. Next, little bit of homework, because to decide with the topic, you have to find out the proper area of interest. So, you have to thorough properly. Not whatever comes to you, you go and read. It is not the idea. What you have to read, you are already in one particular area of interest. The papers which are on that particular area you read, not all papers. Today image processing papers, tomorrow VLSI papers, day after tomorrow wireless papers, not like that, right? Ask a fellow researcher in the same area of this activity will give you a jump start. See, there are many people working on research, right? So if you ask them, they directly will tell you. It will save a lot of your time. Okay. Somebody else is working on their research, they give you their topic directly, you can work on it. You need not make so much of work. Okay, background work. Next. Crack jargons and terms. Understanding the paper sometimes may be difficult. Take help. Okay. Write down your studies. If at all you are writing some paper, if at all you are reading some papers, you write down what are the speculations, what are the interesting problems, not everything. What you find interesting, okay? Possible solutions, random ideas, references to look up, note on papers you have read, outlines of papers to write, and interesting quotes. Okay, so whatever is appearing to be interest, you make a note of it. Then once again you need it, read the paper again. You can see your notes. Okay. Next, bits and pieces. The same thing I have considered here. The basics. Once you have prepared your paper, means these simple things you have to follow when you are preparing. I will spell check the paper. I will check the grammar and punctuation. Is the structure good? Is it well written? Treat it almost like a story. Means there should be some continuation. First you said about the embedded systems introduction. You have gone to some image processing implementation, and you are discussing the results in terms of percentage savings in power. That is not correct, right? The is the argument convincing and does it flow well? Okay, is the presentation good entirely? Have you concluded properly? Next, motivation and structure. So selecting the proper area of interest is one thing, and a clear motivation is required. So what do you want to do? Why are you doing? How did you arrive here? So how do you go about it? The clear motivation you can get two major assumptions and consider them what they have made in the previous research. Okay, whether they are to be changed or they are to be challenged. Okay, that you have to consider from the previous one. Does my paper cover significant new aspects or covered before? Is it covering any new aspect or they are already there and you are doing some simple modification to them? That you have to once again check. See here, these two are not right. Work is not ready. Your work is not ready for journal publication if it is not a significant contribution and differs only in small changes in assumptions and problem setup. Previously they have done it, same thing they have done in 180 nanometer technologies, you want to do it in 90 nanometer technology. That is not for publication. They have used 1.8 volts, you are changing it to 1.5 volts, same thing you have followed, it is not for publication. If you have adopted any new procedure to modify or to change the power savings, naturally you will get power savings compared to them because they are using the power supply voltage 1.8, you are using 1. Naturally power will reduce, right? Why power will reduce? Here it F into VDD square times the voltage, right? So the second one, it is purely methodological and considers a problem of only limited scope or is studied in only a limited way. If it has got a limited scope, we shouldn't present. Okay? It is not for publication. Next. Conducting through research of other work, what others have done, you have to look at it. Okay? Provide a comprehensive, up-to-date critical assessment of what research has been done before. Cite an adequate number of references. This is for your paper. When you are writing a paper, you have to mention what others have done and the references. Ensure that the majority of references are from the last 5 years. Cite high quality of papers. Cite work by other groups, not just your own work. If you have done some previous work, don't mention your papers here, just to become popular. Okay. Cite recent work by the editor-in-chief and editorial board. Let us suppose you want to publish in an international journal. Some editor will write some matter in the first page, right? Editor's comments will be there in the first page. If you select that topic, it will be good because his area of interest is in that now. Okay? That is the simple idea. The structuring of the paper is, anyway I have mentioned it already, the abstract, introduction, existing techniques, design and implementation of the proposed work and your contributions, results and discussions, conclusion of the work, references. So, paper publication abstract. Okay, I am going to conclude in 2 minutes. The abstract here should be of very short, consisting of only a maximum of 200 words. Okay, it should be see here, this is important. The abstract should be a self-contained unit capable of being understood without the benefit of the text. They needed to read all the paper. Okay, when I was doing my research, I take 10 papers, right, in my relevant area. I see the heading. If it is relevant, I take it. Otherwise, I don't take it. If the heading is in my area, I will read the abstract. If it is convincing, I will read the conclusion. Did you get me? I read the conclusion. What they have concluded means whether they have done what they have said they will do in the abstract. Okay. So the conclusion is different means I will not read that paper at all. I will keep it aside. Okay. The conclusion is also interesting. Then I will read the introduction. Did you get me? I read the introduction means I get some basic idea of what they have done. If the basic idea is good, I am able to understand, I am able to follow, then I will read the proposed work. Introduction is not good means I don't read that paper also. Did you get me? So first read the abstract. If you want to read introduction, read, go to conclusion, come back to the work they have done. Okay. Similarly, your document. Okay, so identify the problem, motivation to the work, related work, summarize your methods, summarize the research groups, how they have tackled the problem previously, and what is the structure of the paper, how you have dealt with, what is the related work. Okay. So the proposed work should include all this. The proposed work should have the analysis and design of the work, implementation, discussions of the results, methods adopted, and results, hardware setup, all these discussions. Okay. Essence of the work. Three important key parameters here are significance of the work, originality or novelty, completeness, and correctness. It is not correct means you should not send it for publication. Okay. Don't manipulate for publication. Common mistakes. Unplanned structure of the document. Copied from the previous papers as it is. Okay. If you have to take some content as it is, you take it, but rewrite it again. Don't keep it as it is. Okay. Rewrite the sentences. Use another synonyms. Okay. Wrong sequence in figure and table numbering. Misalignment of columns. Usage of figures from another papers without credit and permission, references not given. Common mistakes. So simple rules to keep it in mind for students. Write the table number and the name of the table on the top of the table. Write the figure number and name of the figure below the figure. Did you get me? If you consider this to be a figure name should be below that. You consider this as a table, the table name should be on the top. Okay, table 1, comparison of so and so. Okay, table name. Okay, if it is a figure 1, log diagram of so and so, like that. Okay, next. If you are using abbreviations, don't use them CU, HCD like this directly. You have to first elaborate and then within brackets you write HCD. Then wherever you want to use the word hardware, software, code design, you need to write all this. You can directly write HCD. Okay. Next. And you have to keep the starting letters in capitals like this. Okay. Avoid using I, we, you, your, our, my, etc. Okay. Many of the students are writing, switch on the system, click on the icon. Who should click? I should click just because I am reading. Don't give punishments or assignments to the reader. They get offended. Okay. I feel bad when I read like that. Okay. Avoid using such words. Then all the figures and tables kept in the document must be quoted or recorded in the text. Just now I mentioned that. Okay. No blank space left there on the top or bottom or in between. Some blank will be there. You don't adjust it, format it, set it properly. Next. Justify the paragraphs. Every paragraph should start with 5 spaces, 1 tab space, or any one of them. Give references in the IEEE format. Okay. So there are 4 choices. Last but one slide. Okay. There are 4 choices. You can go and attend a national conference. There will not be much scrutiny. Okay. In the international conference, the scrutiny may be more, but you will come to know what are the current trends. International conference. You better go and attend an international conference in your area of interest. Next, national journal. Papers in journals are more prestigious considered to the papers in conferences. Okay, so better to have papers in national or international journals. Then journal papers are generally the alpha and omega of the publishing, means they will have the initial and the ending. So standard journals have good impact factor and will have more citations, so you will have better credibility. Okay, so there are a list of journals like this. So I am not at all going to read it out. Very big thank you for your patience.
So they are not going to ask any question. Now the question session is started.
Okay. I'll take 2 more minutes. How to make a paper, not in presentation, it's over. Okay. Don't worry about this. I would like to show you when a document is there, 80 pages or 90 pages report is there, how to make a paper out of the document. Okay, simple thing, I will show you. Please look at the screen. See, chapter 1 is introduction chapter. Okay, so here motivation is present first. I will have to take this motivation to my paper, right? This paragraph is included. Wherever we are including, I will show you. So this is the design actually, the proposed work and implementation of the proposed work, all this is present here. These are the results, these are the simulation results, test benches and all implemented in Cadence. Literature survey should discuss the different present existing low power techniques. The title is, the topic is implementation of a general purpose processor. Okay, low power general purpose processor using self-sleep techniques. That is the title. Okay, abstract we have written, and can I take 5 more minutes? See, abstract is written and the introduction is there for the same. Okay, what is introduction? Introduction included motivation, and what are the existing low power techniques are there, we are writing in the report. All these existing techniques we are not at all going to report in the paper. That's what I wanted to show you. Okay, all these are the existing techniques and mass related work. This is the actual implementation. This is the multi-threshold technique which is existing. Okay, and our proposed system, how we are going to introduce here, you see here, this is self-sleep buffer for distributed empty CMOS design. We are going to use that empty CMOS technique here in the design. Okay, this is Fourier transforms and all you used in this. This is FFT processor, another example. FFT processor block diagram and all, and also the results. These are the results. Okay, discussion of the results is important. All this is present. Okay, I am closing the document now. This is the document prepared, right? Everything is present. Many results are there, references are there, what all should be there I mentioned, it is there. Okay, it is my student's document, so it will be perfect only. Now, see the paper. This is not 2-column paper, this is a single column paper. Okay, I will show you 2-column paper also. Introduction we have mentioned, this is the abstract. Okay, title is this: design of loco F50 using self-sleep buffer with body bias technique. Introduction. Next, what is self-sleep buffer? All this we have explained here. And self-sleep buffer with body bias, that is the actual aim, that is the actual work. That is explained here. What is low power phosphorate transform? That we have explained and kept the corresponding block diagrams. And what are the results? Okay, so these are the results. This type of simulation output is important. How the structure is for the entire design. How the power savings are. Okay, see the comparison tables. Table name should be on the top of the table. Okay, like this. The conclusion, acknowledgements and references. Did you get the thing? Actually, I thought I will show you how I have taken the document from Google, how I have kept it in the literature survey, and how I have taken the introduction for my proposed work, and how I have made this paper. I wanted to show it live because of the time constraints. I am not doing that. Okay, because I have brought another 2-3 examples also. I thought I will show you how to make a paper. Maybe at the end of your project work, I will show you how to do that paper. Okay. So finally, I would like to conclude. Yesterday, I have already mentioned with the VLSI students. Same thing I would like to repeat. Okay. From yesterday's presentation and from previous day before yesterday's presentation, you have understood something about project. Okay. What is the approach? How to plan it? Okay. What are different areas that we can do projects or that you want? Okay. So yesterday in detail, what are the tools that are existing in the college or in your field? What are the different projects that you can go ahead with? They have already discussed with you. Okay, are different areas. Now, yesterday you have collected many eggs. I told yesterday, right? You have collected many eggs from different faculty. All those things are there in your mind. Hatch them properly. Maybe because of overheat, some of them might have spoiled already. But keep at least 2-3 safe. Okay, your area of interest, your interested title, one topic at least safe. So in that area you are going to do the project. If 2-3 eggs are safe, as Professor Vishna sir said, you are going to do the multidisciplinary projects. Okay, and keep at least, let all the eggs are not going to be chicks. At least 2-3 eggs, we want them to become dinosaurs. We want some 2-3 dinosaurs out of 2-3 eggs. Okay, so that it will be an innovative work. Okay, some new innovations they are expecting. Let it be a very good and successful project. Okay, wish you all the best. And see, some of the students are really interested and they will be working. I have already quoted this. I would like to repeat it again. Some students are I can say some 3 groups of students are there. One group of students will make wonders happen. The second group will watch wonders happen. The third group will wonder what happens. Don't fall into the third category. Okay. So I wish you all the best. You select a proper topic. Even we have 3 different projects. I have project from UGC. I have a project working on blind people. We are developing a device for blind people. It is an image processing work. Okay. I need some good students to work along with me. Okay. And we have a project on multi-channel analyzer from ECE also. Okay. I wish you all the best.
Thank you, ma'am. That was a very wonderful presentation, and thank you very much for your valuable suggestions and your information regarding doing the documentation preparation. Okay, before ending the session for the lunch, a small information I want to say. All the WMC students and embedded students, please go for the lunch. The tokens will be available outside. Okay, you can have the token and have the lunch, and exactly we will meet by 1:50 in the same hall. Okay, at the guest lecture itself only the certificate distribution will be happening. Surely you have to be present. Okay, can you leave now? All the VLSI students should be seated. See, please maintain the timing. Don't pause the session. Okay, 1:15 exactly we will meet.
Copy. Just start it.
Okay, on the day 2 of the VLSI system design, we have escaped from the last one session, right? We did not inform them. So let me have the session now itself. I invite Shankar sir to speak, have a lecture on the CMOS full custom design by using cabins. And Joseph Mahmood.
Good afternoon, friends and students. So this is the last lecture for yesterday's series of lecture mark actually. This is also one more powerful full custom CMOS digital design. Many people university here has done based on this area. So basically, full custom means many people will think that only for analogs. So full custom means we can do many miracles by creating the digital circuit design. So the main highlights in this area is VLSI implementation methods. First one is the small preparation and why we go for full custom. So yesterday's class you have gone through the semi-custom designs. So in semi-custom design you know that. So starting is the Verilog coding. Starting is simply the HTML code, maybe Verilog or VHDL whatever it is. So that is semi-custom. The name used is semi-custom. I don't want to again explain what is semi and full. So that is we start with the coding for the semi-custom. Now we will start the other full custom. These are the main highlights I will discuss that. So before going to the here, so we are the implementation methods semi and full, and already semi knows that standard cell library and FPGA based. So we go for full custom. So actually what is the full custom? What is the full custom means? We start from the small point values. Small point in electronics is a MOSFET here. The small point, the small basic building block is in electronics is the MOSFET that will use the miracles for many digital electronics in the industry areas, and many companies come from the starting from the MOSFET only. So MOSFET here is the starting that is the CMOS, very famous one, CMOS. So complementary metal of semiconductor transistor. So we have already other logics. The other logics are very famous in areas: mass transistor logic, downward logic, transmission gate logic, MT CMOS, DT CMOS, VD CMOS. Each logic is a one PhD area. If you go for fast transistor logic, so fast transistor logic means CMOS means we have combined of PMOS and as well as NMOS. So if you want to area efficient projects, you go for the fast transistor logic because only P side is there or only N side transistor there. Just I am giving the area of selection of project which is area efficient projects or power efficient projects or as well as delay efficient, that is time efficient project. Similarly, if we go for area efficient for the fast transistor, for delay efficient there are MT-CMOS, multi-threshold. So based on the threshold values we have gone through the more threshold values, more power dissipation. More threshold values, more power dissipation. So there are two types of threshold voltages, HVT as well as LVT. Anyone knows these two types? HVT and LVT. High threshold voltage and as well as low threshold voltage transistors already available in the cadence tool. This is basically full custom only supported by the cadence designer. So in the cadence designer, LVT cells are there, HVT cells are there. LVT, first of all I will go for the HVT. high threshold voltage transistors. If keyword is a means, high threshold voltage means less power consumption transistors. We have to keep remember that given area must be less power consumption. Your project may be rate of between 3 points, only power, delay and less area. You can only concentrate two, not concentrate on three, because it's never possible to find any transistor logic. There is no transistor logic is done area efficient, power efficient and as well as delay efficient. No single general, no single paper is there in the world based on three efficient things. So you have to be sacrificed two things. It's trade-off. If you go for one plus, one more must be negative. So that is the case here. SVD is for less power consumption and LVD is for HVD cells is for less power consumption as well as switching is more. Switching is when delay is more. If power is less, it provides more delay. As well as LVD, if you go for LVD, the fast LVD means what? Low threshold. Low threshold voltage means the time taken apply for the transistor is less time, yes or not? If you go for low threshold voltage, less voltage is required means less time. So within the less time, your transistor goes on. As well as within the on-off switching is less. As well as power speed, that is speed is more, not power. So drawback of HVD is power less. So I am not going to more details on this. So these are bright custom means these are the three green colors. And one more is not highlighted, that is the thing you already know. So time market is more hard. So I will discuss about there are the PDA methods already know the cadence system, synopsis, metal graphics, as well as channels. So the cadence is the topmost place and our college provides the tools of 29 products already. You know that, and 58 features and 30 users for at a time you can go parallel, and as well as totally we have 58 features totally equal to 30. So totally 1740 licenses must be required. If you want to access full fledged project, you must have each and every license. If one feature missing, you cannot realize your actual design. So 1740 license with full the cadence only. So already this is the full custom design power and tool I am giving simple schematic editor as well as tool. Actual tool has given name is what is the schematic editor? Excel. The name Excel means license version 6. The version is 6.1.6 is right now currently going on, and earlier 3 years back we have 5.196. So right now Excel means 3 versions: L, Excel, GXL. Please do only for your project point of view Excel only. Don't try open with L. If you open L, if you open then Excel, your connection is wrong. Your connection is misplaced. So better to open Excel and end up with Excel only. So for GXL is for high density and research areas. So Excel is the current one. These are the things you already know that: symbol creator, specification and layout, DSS, LES, controls. So now these are things you should be before opening the tool. You should keep in mind that the tools for like CMOS, GPDK must be defined to select the transistor from there. Now before going to the project, the particular things are there on the checklist. So once opening the tool, so these are the things: NMOS, PMOS, symbols, and colors. DRC load file is defined. How the DRC errors will check, and already the file is loaded into that. So you have to check the file what is actually internal. In the time of laboratory, we are not actually focusing on what is DRC file. At least right now onwards, during the project works, please concentrate on what is the DRC file, what are the rules for that. At least before starting that one, please concentrate DRC rule file, LDS rule file, as well as some other things. So these are the current technologies. LDM about micron, that is 1 micrometer, and submicron 0.18, and one more greater than 0.18, deep submicron less than that. And actually the current trend is going on nanometer. Basically nanometer less than 100 nanometers actually, but our college provides 180, that's 90 and less 40, fine. Better to start your project at 45 because it will give more efficient your design. And on very recently I will tell you just the information I will give you. TSMC is the biggest. TSMC is a library manufacturer, that is library company, library provider, as well as Cadence is a tool provider. They are collaboratively found a film factor, a new version technology, that is 16 nanometer technology. Now it is in research areas. It's not having used. So these are the current trends technologies, and GPDK 45 supports 11 layers of the metal layers, as well as GPDK 19 supports 9 layers. So these are the versions. Why you go for GPDK 90, GPDK 45? Please at least differentiate these things. As well as BTH also varies. BTH values also varies. So So if you want to go for CPTK 45, your circuit must be complex. Circuit must be complex in the sense your design must be very large. Then only go for the 45, and then you go for large things. See, we have given here. Depending on your circuit complexity, select your design, select your particular CPTK. So better to have almost 6 or 7 layers. So it is better to choose 45 NM already available. So actually this is a summary of whole things. Actually, what are the things to do a digital design project in full custom? These are the summary of very 7 points you have to remember. Similarly, you know that very long. So for very long, a big project, how many modules are there in the internally? For doing a very long coding, a top module is there as well as in that very small modules are there. So combining together, we can say the top module. Similarly, we have the same situations. Schematics, small schematics combined together made as a big schematic at final stage, and we have to do for that symbol, for top model symbol, and then the spectral simulation is already done, and top level design, top layout design you do for the individual layout simulations as well as top layout, top model layout simulation also. So this is the one, and physical verification. There are 2 things here. These things, DRC, extraction, LVS. So you know that extraction and DRC and LVS. What is the importance of extraction? Can you tell me once? Extraction. Any parasitic capacitors or any some other elements are coming, you cannot avoid it. That is unnecessarily coming, you cannot avoid by using any techniques. You have to be do with that only. So with that, if you know that, according to that, your design will get how much delay. If you get more parasitics, you have to analyze your design it has more delays. So similarly, MPS change and everything here. Post layout simulation is a sign off. You have to do the project up to the post layout simulation. You are not going to generate GDS file for foundry. We are only taking the projects based on up to the post layout simulation. So these are the areas we want to do the projects. A digital circuit base, you have to choose if you have to implement APK adders and multiple as well as bands, many things here. Now this is microprocessor. So you have to select the full custom is better option. Only last, not but least, I will tell you the why full custom is many options are there in full custom tools to optimize your design simply. Many options. For purpose semi-custom, very less options. You can design your circuit, you can design your project perfect shape. There are many options because you are going for full custom. If you want to sacrifice some features, you go for the semi-custom. These are the why you are going for the full custom. Remaining one example, madam will explain. Clear.
Okay, so sir told you about what cadence tools, what is the method of doing the cadence tools and all that just now. So I'll take an example, that is a boost multiplier CMOS design. You learned different multipliers. Just take one example and I'll tell you. So first what you should do in your project is if you want to do in cadence, you have to settle it, like take the domains like you want to do on RAM or ALU or adders or your PLLs. You have different examples. I'm just taking a very small example and telling you. Don't think you can do a multiplier for your M.Tech project. You can do ADCs, DACs, you have regulators, so many examples. So first, very important thing is when you see your IEEE paper, the block diagram is very important. So look at the block diagram. I'll put a block diagram here. So what are the different blocks you have in this block diagram? You have a control unit, you have a register, adder and subtractor unit. You have another big unit, the name is not given for this unit, and then you have a mux and a 2-bit down counter. So all are the different blocks in this unit. So what is your first aim? What you should do? First, in your IEEE paper, don't expect that they give you all the blocks. Suppose you have the blocks 1, 2, 3, 4, 5, 6 blocks here. Okay, they may give you in your paper only 4 blocks. So the other 2 blocks you should search in the other IEEE papers, put it in your design, synchronize it and get your output. Okay, so now let us start. So I think just now sir told you the order. And you have learned in your M.Tech lab what is the first thing you should design schematic, then the symbol, and then your test bench, and then your simulation. Okay, layout is a different procedure. If you want to find out the area, you go for the layout. Okay, so now in your design, here suppose there is a 4-bit register. The registers are made with flip-flops. I think all of you know it. Mostly take a D flip-flop. Then you have the mux, And then you have some adders. Adders complete, you can make an adder with a NAND gate. Is it correct? So these are the main blocks. So you have to start with a leaf cell. What is the meaning of a leaf cell? You have to first design an inverter, an AND gate or an OR gate or MUX, whichever you want. This MUX, all you do is to one MUX. So you have to start with the leaf cells. So all of you know this is a basic inverter schematic. So you are first starting with the inverter schematic. This is your schematic and this is your symbol. And then this is your test bench. You will test whether it's working or not. And then you can see the waveforms. You're checking whether input and output is coming. And then if you want to calculate the area, that time you go for the layout. This is the inverter layout. All of you have learned it how to calculate the layout. Okay. The next one is in the layout also we have the extracted version. So you're finding out the internal parasitic resistance and capacitances. Then after this, after the extraction version again you do the post layout estimation because you're checking whether your schematic is matching with your layout. After this you're going for the next block like NAND. Again the NAND gate schematic, again it's layout, I'm not going deep layout. Again after that you go for a full adder using your basic versions, you go for the full adder, then a D flip-flop and then you go for a register. So now you have designed the 4-bit register. After this, after designing the register, this is your symbol for the register, 4-bit register. This is your layout. You can see the layout for a 4-bit register. And then this is the top leg. Now I came directly to the top leg. So I was just telling you the leaf cells, inverter, NAND and all that. So when I say top level, what is the meaning? Inside your block diagram, you have some blocks like control unit. It is not given in your paper. You have to search for the control unit. You have to synchronize all this. You have to put the control unit there. So first what you should do, you should find out the output of the control unit, whether it's coming directly or not. Output of the D flip-flop, output of the register, all this. And then you have to synchronize all these blocks together. So this is the final diagram after you have synchronized all your blocks and you are checking whether you are getting the output or not. This is the final stage of it. Then after finding out, you should put some results in your paper. Simply you cannot say I have designed a boost multiplier, they won't agree. But you should have a column called as results column. What do you put in the results? You have to calculate the delay. When I say delay, it is nothing but speed. I think all of you know it. Okay, you have to calculate the delay. Then inside your tool, when you go to your launch adder platform, there is a launch and inside the launch you have a calculator. So uses the calculator window when it is open. Using the calculator, you can calculate the delay. Okay. So this is the delay calculations. So we have a book in our VLSI lab now. The time constraint is very important here. So we have a book, cadence book in the VLSI lab. You can just go through the book very deeply. Everything is given how to calculate the delay. And you can see here, I think it is very small. The delay value, I think you can see here, 57.53. It is coming as picoseconds. It's very less delay. Okay, it's for a 90 nanometer technology. So if your delay is coming up here. It then calculate the delay. In a similar manner, you can calculate the power also. So once again, to calculate the power, you use the calculator. There is a calculator option in the tool. Using the calculator option, you calculate the power also, the power of your entire block. And coming to the results, this is very important. At the end, you have to put the results. So here I have just given some very few examples. Like, see, maybe your paper is already done in 180 nanometer technology. You can do your project in 90 nanometer or 45 nanometer. So when it is like power, what is the power supply for 180, what is the power supply for 90, and your 45, this you can vary according to your requirement. Then what is your delay, what is your power, what is the area, you calculate the area from the layout. So this is very compulsory that you have to put in the last of your project. Okay, so this is how you do a project in cadence, that is transistor level version. Thank you.
Thanks for the report. So go for the lunch. The tokens are available outside. Collect the classes and assemble at 1:50 sharp. 1:15.